So now that we know all about the transformations and what type of transformations we have, one of the first things we would like to do with it is just to rewrite a function having a described transformation. So in this first round, we're going to basically use the basic function, the cube root of x. And so what I'd like to do is rewrite the function, right, a new function that would be the cube root of x, but only shifted up 5. So notationally, that means I got to take whatever my function is, and if I'm going to shift up, I've got to add 5. So again, we're taking all our y values and adding 5. Well, if my function is the cube root of x, then we're basically, I should have put y equals, we're looking at y equals the cube root of x plus 5. So there would be the way that I would take the old function, the cube root of x, and I would take all of its y values and shift them up 5. If I wanted to shift to the right, this is impacting the input values. So from our previous knowledge, we know to get a shift to go to the right, we're actually going to subtract 2. Sorry about that. Okay? And so for the function that I have up here, right, that would be the cubed root of x minus 2. All right? And that's basically going to get our graph, the cube root of x graph, that, again, that shape pretty much looks like this. Right, that's going to get that graph to shift over 2. Well, this is going to get to shift up once. I want to vertically stretch it by 3. Well, again, from what we've learned, that basically means we're taking some a, right, and multiplying it to the f of x. Well, in this case, a is 3, since we're going to be stretching it by 3. So for the function we have, this is 3, the cubed root of x. So that would be the function that basically stretches out by 3. This would be the function that moves it over to the right 2, and this would be the function that basically shifts it up 5. So how do I write a function that has all 3 characteristics? Well, again, notationally, that would be 3 times f of x minus 2, and then plus 5. So whatever the function is, this is telling us to shift to the right. This multiplication of the function is getting us to stretch 3, and then this plus 5 is basically getting us to shift up. So for the function that we have 3, the cube root of x minus 2, and plus 5. And so that would be the function that is based off of the cube root of x function, but shifted up 5, shifted up to the right 2, and then it has a vertical stretch of 3. And so that's basically how we do each one by itself and then putting them all together. Of course, we can go to our graphing calculator to kind of verify all that, which I will do. So we'll go to, let me turn this on. We'll go to y equals. And first, how about I just type in the cube root function. So we'll go to math, and we got that function there. Right, and I'll type in x, and I'll enter. So there's our basic function, and then what I'd like to do is get the graph to go 3. Right, I'm going to put this in parentheses just so that we get a clear multiplication going on. Math and cube root, we want x minus 2, and delete that. Come out, and then plus 5. So I don't think you might be okay without the parentheses. I just want to make sure that we're multiplying 3 to the cube root of x minus 2 and then plus 5. So when I go graph this, here's your basic function, the cube root of x. All right, and then what we're going to see is a function that's been shifted over to the right and shifted up, and it's vertically stretched out by a factor of 3. So that point, let me go ahead and let me just check my window. Yeah, so let's go from -10. Let's get back to our standard viewing rectangle, so we can probably, we're zoomed out a little bit there. I should have checked that at the beginning. All right, so there's our standard function, right? The cube root of x, looking like it should. And then here's the one that's been basically shifted over 2, up 5, and then you can see it's been stretched. So that point right there, you'll notice that it's 1, 2. There's 0, 0, where that kind of S shape occurs. It's been moved over twice. It's been shifted up 5. And then, of course, that graph, you can see that it's been physically elongated. So it does everything that we said it did. So There it is for the shift up, there it is for the shift right, there it is for the stretch, and there it is all together. Okay, so let's do this one more time. In the next one, the basic function is x squared, so it's our parabolic function. Again, that looks like so. Going again through 0, 0, and how do I get it to shift down? Well, that's whatever my function is, subtract 4. So in this case, that would be x squared minus 4. How do I get it to shift left? Well, using our notation, that's f of x plus 3. And so for this function, this would be x plus 3 squared. How would I get it to reflect through the x-axis? Right, so that means we're essentially negating whatever my function is. So for this, that would be negative x squared. How do I get it to vertically compress? Well, that would be y and 1/2 of f of x. So this would be 1/2 x squared. So those are all the different transformations individually, transforming the function x squared, shifting it down 4, shifting it left 3, reflecting it through the x-axis, which means it's now going to be opening downwards, and then basically compressing it. All right, so I'm going to expect, before we go graph this, when we put it all together here, right, which I'll show shortly, the vertex, right, this 0, 0 is going to move down 4, right, it's going to move to the left 3, and then it's going to be reflected down, and it's going to be a little flatter. How do we put that in my graphing calculator? Well, putting this all together, right, what it would be is y equals, well, the negative 1/2 does two things, right? The negative causes the reflection through the x-axis. The half causes the compression. To get the shift left, right, we need an x plus 3 in there. And then to get the shift down, we need a minus 4. So that's what that would look like using the function. Of course, replacing that with what I have, we get negative 1/2 x plus 3 squared minus 4. And so that is what I'm going to put on my graphing calculator. And we're going to see it's going to be basically our quadratic shape. But again, it's going to be moved down 4 to the left 3. So 1, 2, 3, 4, 1, 2, 3. And it's going to look a little flatter, and it's going to be going downwards. So let's go ahead and just verify that with our graphing calculator. Let me go ahead and clear that out. And let me type in our basic function. We got x squared. So there's the basic function, and then the one we're graphing, make sure you use the right negative, right? It's negative 1 divided by 2. And again, I like to put that in parentheses, so I'm a little stickler on that. So negative 1/2, right? And then another set of parentheses, we have x plus 3. We're going to square that, and then we're going to subtract 4. Okay, and so when I go graph that, there's our basic function x squared, and then here's the one that I'm predicting. So notice that that point, right, what used to be the origin here, that bottoming out, right, has gone down 1, 2, 3, 4, and shifted to the left 1, 2, 3. It's reflecting downwards, right, so it's no longer going up, it's going down, and it's also a little bit flatter. Not a whole bunch, because we're only multiplying it by 1/2. So there you have it. What we basically did then is given a new function, how do I write a new function that makes it shift up or down, shift left or right, reflect, right, stretch, and compress, and then putting them all together. And so we can begin to see that this helps us eventually graph. You notice that I would graph it without using the graphing calculator, and we'll build up to that. But there's basically a real quick application of all the transformations that we just discussed in writing, taking a function and rewriting it as new functions. So I have 4 different ways to write the cube root of x up here, and I actually have 5 different ways to write the x squared function. Of course, there's infinite number of answers depending on how far up or down you want to shift, how far left or right you want to shift, how much do you want to vertically stretch or compress, do you want to reflect through the x-axis, do you want to reflect through the y-axis, do you want to put it all together. So lots of ways to manipulate our basic functions. That's just a start. We'll do more coming in some videos soon.